Retchless for joining me today. Would you like to tell us a little bit about your research and the type of work that you do?
Yeah, absolutely. First of all, thank you, Dr. Ross, for the invitation. I really appreciate it.
Yeah.
So my own work is related to understanding the role of geospatial tools in mediating our perception of the coastal environment with a focus on natural hazards and the impacts of climate change. So more specifically, I've looked at interactive web maps, augmented reality tools, and hazards including storm surge from hurricanes and the effects of sea level rise.
Mm-hmm.
And I'm interested in how small changes to the design might affect people's interpretation of information about these hazards. And I don't see it, though, as a simple matter of conveying information, but also I believe that the tools themselves often carry important emotional valence that can color people's perception of the hazard in a way that influences their understanding of risk. So I think the emotional components are important in addition to just trying to improve people's understanding of these hazards. And I think the tools have a role to play there.
Can you give us an example of how someone might have emotional valence towards a certain tool?
Yeah, so some people might, for example, view a tool showing a sea level rise scenario for a place, say, that they don't know well,
Mm-hmm.
and think, oh, well, that's interesting. But if you show that to someone who lives in that community, has deep roots in the community,
Mm-hmm.
they might have a much stronger emotional reaction to the tool showing, direct threat to their life and property.
Sure, so
actually.
tapping into some of those sense of place, sense of
Yeah.
belonging.
Mm-hmm.
Does it also get, in terms of labeling at things like political ideology and values?
Yes, so that's something that I've looked at as well, and thank you for that. In addition to looking directly at how these tools affect risk perceptions and understanding of coastal hazards, I'm also interested in how things that the map or tool user brings to their interaction with the media in turn affects their risk perceptions or understanding. And among those individual differences that I'm interested in is differences in political ideology, worldview, whether you tend to be more of a hierarchical individualist, right, or a communitarian, and some of those different worldviews that have been shown to be correlated with
right.
Different policy views, and in some cases perceptions of risk for some more politically charged hazards like climate change in particular.
Right. So what projects are you working on currently?
Right now I am working on preparing some manuscripts that came out of my dissertation work, which was related to sea level rise in the Sarasota, Florida area. So I'd be happy to share a little bit of that with share that with the class. So this is an interactive web map that I prepared for my dissertation work, showing sea level rise in the Sarasota, Florida area, providing some instructions for users when they first launch the app there, but I'll just close that out. So one thing that I haven't mentioned yet that I occasionally try to address in my work is thinking about the uncertainty that's inherent in these products as well. So in addition to communicating information about likely levels of flooding, for example, under different storm surge or sea level rise scenarios, there's often some uncertainty inherent in those predictions. So thinking about how to communicate that to audiences and how different audiences might interpret that uncertainty. So for this project, I looked at two different kinds of uncertainty. Uncertainty in sea level rise projections, which was communicated via this annotated legend and slider tool up here, and then also for any given sea level rise scenario, because our ability to measure the elevation of the land at any given point is somewhat limited. There's uncertainty inherent there as well, so we can look at the probability for a given amount of sea level rise that any given location will flood. So there's some uncertainty expressed there directly on the map in terms of these probabilities of flooding from low to very high. So that was one thing that I looked at here with this tool. But the interactive map itself was just one part of a larger project. So it was connected to this survey, which included a tutorial and the interactive map, a couple different versions of that map. Interestingly, one thing that I asked about was people's emotional reaction to the map using this tool here, something called the Geneva Emotion Wheel. And that is what I'm currently working on writing up, the results from that component of my dissertation work, looking at how people's emotional reactions to their time spent interacting with the map varied based on some of their individual differences, as well as looking at how the types of interactions they had with the map, pans, zooms, clicks on certain links, how those might be associated with different emotional responses to the map tool. So that's what I'm currently working on for my dissertation work. I recently published sort of the core of my dissertation project in environment and behavior, looking at...
Which is one of the best journals, right?
It is one of the better journals for my field, so I was very happy to get that article published there. But that looked more at the association between people's physical location, either right there in the Sarasota metro area, very close to the sea level rise hazard, or students distant from the hazard up at Penn State, and then also prior beliefs about climate change, and how these factors that the map users brought to their interaction with the tool in turn affected their risk perceptions.
So what are you finding with the emotional side of it and location, geography?
Yeah, so I'll speak to the second part first. I found that somewhat surprisingly, people seem to be a bit more responsive to the map if they were distant from the hazard. The Penn State respondents showed a larger increase in risk perceptions from pre to post map interaction. And I hypothesized that that's due to potentially a couple of factors. First of all, Sarasota respondents may have had a bit of a protective reaction to viewing this information. They are more invested in the place, and therefore it might be a little bit more difficult for them to update their risk perceptions based on new information. There's more at stake for them. But also a part of it may have been that for my Penn State respondents, they didn't know a whole lot about the area before viewing the tool. The risk perceptions tended to be a bit lower going in, and so they had further to rise.
Right.
So that was part of it. I think the potentially more interesting result was that the largest increases in risk perceptions when you look at people with different beliefs about climate change going into their interactions with the tool were among those who were initially somewhat cautious or doubtful about climate change. And not those who were entirely dismissive,
right,
or those who were disengaged with the issue. They didn't show much change in their risk perceptions, but among those who were just a little bit cautious, not sure what to make of climate change, they initially had somewhat lower risk perceptions for sea level rise in Sarasota, but after working with the tool, the risk perceptions were significantly higher.
That's really promising for application. Because a large percentage of the population does fall in that kind of doubtful category.
Right.
They're not totally convinced.
Right.
But they're not also deniers.
Right.
Yeah.
And so my thought in developing the tool was that, well, if you show people in those groups, the middle of the road groups in terms of their views on climate change, if you show them real world, on the ground impacts of sea level rise, so not just on the map, but included in the survey, I had these little pop-up windows showing
actual
pictures of different places that might be impacted by sea level rise, and a brief description of why these places are important to the Sarasota community. And I didn't test, I didn't pull apart which specific components of this maybe were responsible for that effect, whether it was just the map or the inclusion of these little vignettes or both. But in any case, when the respondents saw both of these in combination, they came in a bit skeptical about climate change and more specifically sea level rise in Sarasota. They came away with somewhat higher risk perceptions for Sarasota sea level rise. So that was promising and kind of exciting.
It's very promising.
So I've enjoyed that work. As I said, I'm now focusing on this emotional response component as well as looking at some data that I collected on the map interactions, where people clicked, how many times they clicked and used different features, and trying to look at an association between that map interaction and people's emotional state following the interaction. So I'm hoping to get that one additional paper published out of the dissertation. There's another paper out there that came out of the dissertation prior to starting my time down here at A&M Galveston, and that was a little bit more of the lit review section. Potentially worth looking at as well.
Yeah, that's great.
More recently, I have shifted gears a bit to looking at augmented reality as a potential tool for communicating coastal hazards.
What do you mean by that?
So basically the way I describe it to a lot of folks is it's sort of, my tool in particular is Pokemon Go-esque, but for storm surge flooding.
Yeah.
So you hold up your cell phone, it gives you a alternative window
of what
reality.
You're looking at.
Right, so you see your camera view, and it looks pretty much like what you would see just directly through your eyes, except I've added augmentations to the view. And in this case, the augmentations are little stick figures that show the level of storm surge flooding under different storm scenarios and adjusted to match the height of the user.
So where that little stick figure is standing, like imagine that
Yeah.
level is where the storm surge water would be.
Right. So there's, in the case of this tool, there's one stick figure per structure
Mm-hmm.
here on the A&M Galveston campus, and it's actually a flood level, average flood level over the footprint for that building. So you would expect the water level to be, for example, for our Ocean and Coastal Sciences building, under, I think this was the Hurricane Ike scenario, you'd expect the flood level to be right at about your knees if you were standing
which is
in
on the
front of
stick
the
figure.
building.
Yeah, cool.
It's about 1 to 2 foot flood depth. So, and you can click or tap on each individual stick figure to get these details.
data.
So the
Yeah.
specific flood depth, the name of the building, and
That's really cool.
so I misspoke slightly. This scenario being shown here is a 100-year
Yeah.
storm with current infrastructure. There are also some scenarios here that show the potential effects of building an Ike Dike or one of the coastal spine protection scenarios, and how that
Could change
dramatically lessens, in most cases, the storm surge flood depths. So you're a little less likely to have water up at your shoulders or your chin if we build the coastal spine
Right.
for most buildings here on campus, which
That's a good thing.
yeah, for sure. And one of the things that I'm hoping to eventually do is run another survey with this and look at the effects of using this tool on risk perceptions.
Very cool. So a lot of your research, if not all of it, has really users in mind and average citizens.
Yes.
So can you tell us a little bit about what you have in mind when you're thinking about those types of users of information and how you communicate that clearly from an academic standpoint?
Yeah, so it's definitely a challenge. I mean, some of this coastal flood data on the surface seems pretty simple. So, okay, where's there going to be water and how deep is it going to be? I learned fairly quickly during my dissertation work that behind the scenes, there's a lot more involved here in terms of, what sort of tidal situation are we in? Are we talking high tide or low tide? And what datum? So how are we measuring that tidal height according to what reference point, essentially?
Right.
So there's a lot of information in the background that if you start trying to pull this apart, potentially needs to be communicated to the user. So you might have a small subset of users who look at this and say, okay, that's great, that's interesting, but how did you figure this out? How did you figure that out? And so I like to try to provide that information, not at the first pass, because I don't want to overwhelm the user, but I like to make it available so that the more interested users, particularly for a controversial subject like climate change or sea level rise, can click on a little info button and follow the breadcrumbs and learn how I got to the product that I presented, so that there's sort of an honesty in the presentation, and the users can see that I'm not just making this up out of thin air. It's coming from these sources. It's supported by these references. So I think that is really important. But at the same time, you can't overwhelm the user. You've got to keep it really simple in that initial presentation to capture their attention, to provide just the most relevant bits of information. So for the augmented reality view, I thought about what's the thing that people probably most want to know about storm surge, and there are probably two things that they want to know: how deep will it be, and sort of how likely is it that it will be that deep. And in the case of this augmented reality tool, what I tried to do was communicate that likelihood information in terms of different storm scenarios.
Right.
And I already discussed earlier some of the ways in which I tried to communicate probability or uncertainty in the sea level rise context. But I think it's important to include that information as well, the probability information, the uncertainty information. Maybe not as the first presentation, but make it pretty clearly accessible, and explain those uncertainties, acknowledge them up front. I've had some folks that I've interacted with at conferences suggest, oh, well, really what you need to do is go with the most extreme scenario.
To scare people.
Scare the Jesus out of people. Yeah, exactly. And I think that that's potentially not a productive approach. Some of the literature has shown that if you just scare people, you'll get their attention, but then you, for many people, will trigger a sense of hopelessness.
Can't do anything about
it. Right. Fatalistic perspective, whereby because people feel they can't do anything about it, they'll throw up their hands and say, well, it's going to happen or it's not going to happen. I can't do anything, so I'm just going to continue about my life, as I have in the past. Which is probably not an unreasonable response to
but it's
an
not
overwhelming
productive
threat, but it's not productive. So what's been suggested in the literature is you have to, if you're going to scare people, provide them with concrete steps that they can take to really address the problem. Give them a sense of control. So it's scary, but wait, you can do something to make it a little bit less scary. So I think that's part of it, and I haven't integrated that component to the augmented reality viewer yet, but in the interactive web map for my dissertation work, there was a sidebar that provides a lot more information about sea level rise, including steps that people can take to reduce emissions, and then at a local, more immediate level, things that people can do to prepare for flood events and protect their property and family. So I think that's part of it. Another part of it is maybe don't go so extreme and show a very unlikely scenario that's highly dramatic right away. Maybe put that as an option in the tool so people can see those high-end scenarios and explore them. But start with more middle-of-the-road scenarios, things that people think are likely to happen within the lifetime of your users.
I think this is so great because it really engages people with the information and the scientific process, because you're communicating to them that yes, in science we have uncertainty, and that's inherent to what we study, but we shouldn't be afraid of that. And we shouldn't also just be accepting of the extreme event. There's a range of possibilities here. Let's all be aware of them and informed, and you're giving them the tools to interact with that information in a transparent way. And I think that's really creative, it's really unique, and I think that's also what we have to do to raise awareness and concern about issues that have become controversial, like climate change, because they're not just bipolar, where you have one extreme or the other. There's definitely a range of impacts that are happening.
And I think that one of the directions in which I'd like to take my work is previously I had done a lot of survey work, often online, occasionally in person. I'd like to move a little bit more towards doing some focus group work as well, because I really would like to know what people actually think about this uncertainty information. Do they understand it? How are they interpreting it? Are some people looking at it and using it as a reason to dismiss the information entirely? You know, if that is more comfortable for them and is maybe more in agreement with their worldviews.
Yeah,
exactly. Or are people really engaging in the way that you suggest with the scientific process and moving towards an understanding of the uncertainties inherent in scientific research, not as something that calls the scientific method into question, but as something that really gives them a deeper understanding and appreciation of how science works and what uncertainties mean.
Because in their everyday lives,
Yes, well, that too. And I think that when we use uncertainty and talk about our results being uncertain, we often mean a very different thing than what most people think. So, you know,
exploring that would be really valuable.
Absolutely. I think often people will see or hear about there being some uncertainty to a scientific prediction or projection.
Especially with climate change.
Yes, and they will say, "Oh, well, it's uncertain, so
completely
throw it all out." Yeah, they don't even know what they're talking about. They can't say anything with certainty. So why should I believe or give any thought to this? But that's not what we mean when we talk about uncertainty and confidence intervals.
Right.
It's our best attempt to come to terms with a complex system.
Right.
And it's often we're quite confident, we just can't say it with 100% certainty.
Right.
And so trying to communicate that and get that across.
That's great.
I'd like to know how people are actually grappling with it in a richer sense than I can get just via surveys.
With clicks, that's really great. Well, last kind of part of this little interview, could you tell us a little bit about the classes you teach, the students you interact with, and then if you have any little tidbit of something that we don't know about you.
Sure.
To get to know you better.
Yeah, so over my first couple of years down here at Galveston, I have taught 2 courses. So Introduction to GIS at the undergraduate level, and then also Marine Geography. In Intro to GIS, students learn more about basic geographic concepts within the specific space of the Esri tool set. So ArcGIS, we use ArcMap and a little bit of ArcCatalog, which is the database management side of ArcMap. And these are the sort of the industry standard tools, which although to an increasing extent some GIS work is moving online and towards open source, if you're going to work in government or for a consulting firm, or most large companies that use GIS will still be using ArcGIS tools.
Right.
So we still feel that it's important to focus on these tools and to give students a strong background in them. So students learn about different geographic data types, raster, vector, learn how to make maps, learn how to perform some basic spatial analyses. And at the end of the course, they put together a project on a topic of their own choosing, using GIS tools to try to answer a question that they have. And it's been really successful so far. We've had some really good projects. It's been a lot of fun working with students. Some of the quirks of GIS software and the more esoteric geospatial concepts are occasionally a challenge. Students will get hung up on them. But it's really rewarding to see the light bulb come on and students get it. And in some cases really change their understanding of not just the tool, but how we make sense of space and codify it in a GIS environment, which I think is a really important skill to have, even if you're never going to use GIS software in the future, given that so much of our world now is, our understanding of it is mediated through tools like augmented reality and Google Maps.
And so much of what we do is place-based,
yes.
Even on our phones.
Yep.
Yeah.
Yep. So I've really enjoyed that course. The other course that I've taught, marine geography, I won't be offering it this year, but potentially in future years again. That is a little bit more of an intro level course. It provides some of the basics of geomorphology, but also I've increasingly tried to stress the role of human environment interactions in that course. So we not only look at coastal processes, but also coastal hazards and the relationship between coastal processes, hazards, and society.
That's great.
So in that course, we don't use GIS tools, at least formal ones like ArcMap, but I do ask students to get their feet wet with Google Earth and do some exploratory exercises, find examples of different landforms and different types of human habitation along the coast, and we use those as sort of a jumping off point for some discussions and group projects. So I've enjoyed teaching that course. I hope that I'll have a chance to teach it again in the future. This fall I'm offering Geography 665 for the first time, which is part of our course sequence for our new GIS graduate certificate program. So that's going to be a course that's focused a little bit more on GIS modeling. So we're going to be using Model Builder, which is sort of a flowchart-like tool for putting together models for analyzing geospatial data, and then also a little bit of Python programming to try to get students up to speed on the latest for spatial modeling within the ARC platform. So those are the 3 courses that I have right now. I've enjoyed working with undergrads thus far. I'm looking forward to teaching grad students this fall. I've had good experiences advising them, but it will, I think, be a fun experience to get into the classroom with grads this fall as well.
Absolutely. Well, thanks so much for your time today.
Oh,
you're not. Are you going to tell us something about yourself?
I just realized, I forgot to share something interesting.
I didn't want to press you on it.
Yeah, no, I didn't want the students to walk away thinking that I had nothing interesting to share. That
I'm sure you have tons.
So I was thinking about this, and what can I share? Students may not know, I don't consider myself an avid cyclist, but I do very much enjoy getting on the bike and going for a ride. Haven't done it much since moving down here to Texas with the heat and all that, but in the process of tracking down a road bike so that I can join my local cycling club.
Cool.
And so you may at some point, if you're driving around Pearland, see me out on the road with the helmet on.
Be friendly, everyone.
Exactly, please, give me a little space on the shoulder.
That's cool. Where's the best bike route? Like the prettiest that you've ever been on, most memorable?
Probably there was a loop around State College, Pennsylvania that I would take through some rolling hills and farmland, and I think it was known as the zebra loop because there was a zebra that grazed at some point along the route. So you knew you were on the right track if you saw the zebra. If you'd been going for more than 20 or 30 miles and you hadn't seen the zebra yet, you'd made a wrong turn.
Wow,
So,
I'm pretty sure I wouldn't make it, but that's good.
yeah.
Well, thanks so much for your time.
Yeah,
and
thanks, Ashley. I
This is really
appreciate it.
interesting. Yeah, thanks a lot.
Yep.